talks about the vectors and dot product. To remind you, the dot product is, in geometric terms, the length of A times the length of B times cosine theta. Okay? That's the geometric version of the dot product. Okay? So let's move on to the applications of the dot product. Say we want to find angles and lengths. So we can find the angles cosine theta. And so say we want to find cosine theta using vectors. What we can do, I'm not going to derive this, but I'm just going to give you the equation. It's A dotted with B divided by the length of A dotted with the length of B. Okay? And there's a whole derivation about this if you want to watch it, but I'm just going to give you the formula because it's very important per se. It's in our next example it's going to come up. So let's say we want to find, so let's do an example of this. So let's say we have a triangle in space with vertices P is 1, 0, 0, Q, which is 0, 1, 0, and then R, which is 0, 0, 2. Okay? So I'm just going to draw this picture out. Okay, so if we go here is 1. So there we go. So the question is asking, what's the angle of P? Well, we can express these P, Q, and R in terms of vectors. So we can start at P and express Q in terms of PQ and R and PR. So we'll get PQ and then PR. Okay? So use the vectors. And essentially, you dot them, you just dot the vectors P and Q and R. Alright? So now we want to find the angle. We use this formula up here that we just saw. So we would get cosine theta is equal to, well, that'll be negative 1, 1, 0, dotted with negative 1, 0, 2, divided by, so the length of PQ, which will be root 2, and root 5. Okay? Now again, we just simplify this. It'll give us 1 over root 10. Okay? So that's the answer for cosine theta. But we're looking for the angle theta. So if we just do the inverse cosine on both sides, so we get inverse cosine of 1 over root 10 is equal to 71.5 degrees, approximately. Okay, and y is a positive sign is below 90 degrees. If it was 91 degrees, it would be negative. Okay, so that has been an application of the dot product.